Anyone need a copy? The exams are a little different. There's not any kind of lecture. The way this course is structured, we go back to the, oops. We go back to kind of the timeline for the course. 2-6, 2-6, 2-7, 2-7, 2-8, 2-8. They gave us 2 days for every section in chapter 2. And then later on, you know, some of them overlap, but most of them, when we get closer to the exam, they overlap. But most of them, we only have 1 day for lecture. So there's not anything new necessarily to lecture over 2.6, so I thought this would be a good time to kind of go over 2.3 and 2.6 work type problems, exam type problems, and how to, you know, accept you notation wise. You guys are using ALEX, so I try to, you know, also look at ALEX type problems. In math, this never really comes up. They never give you this picture with numbers on one side and the other side and then arrows. But I figured ALEX is expecting you to know the answer, so I wanted to go off them. So we have 4 relationships. Relationship 1 is a function or not a function?
Yeah.
It is a function, right? There's no problem. This would also kind of represent a horizontal line, right? Your domain is the x-axis. Your range is your y-axis. Your range can only be 1 number. That's perfectly fine, right? Everything in -8. When you get in all your domain, there's only 1 thing in your domain, and it's going to multiple things in your range, right? So this is a function. Again, I apologize for the quality. The printer is really low in toner, so got what you got. Relationship 2, is this a function or not a function? It's not. Our problem comes with it can't be mapped into S and D separately. Okay. What about relationship 3? Hard. It's not, right? I have a problem when -3 goes to 3, and then -3 goes to 4, then -3 goes to 9. So not a function. Relationship 4, not a function again. K and G goes to G, which gives me problems. Anytime my X goes to more than 1 Y, you can think of X going to more than 1 Y, I have a vertical line. Vertical lines are issues with the vertical line test. You'll also be asked to kind of simplify or be able to evaluate functions. So functions F and G are defined as follows. Simplify your answer. So what is F of 3? -7. So notation-wise, you F of 3. I'm answering this question. It's -3, open parentheses 3 plus 2. So that tells me you can work vertically if you like or horizontally. It doesn't matter. Consistent. That tells me -3 times 3, so -9 plus 2. You kind of do that in your head and you get a wrong number. I can't tell what you're doing, so you won't get any partial credit. This is a 5-point problem, and maybe and you wrote -11, I could just take off 1 point because I could see you understand you're plugging in 3 here. You got -9, you added 2, you just did that wrong in your calculator, or you hit a wrong button, or your brain went crazy, and because that happens all the time. Students will come up to me like, no, I knew that, I just didn't. I'm like, that's great, I can't see you knew that. So as far as partial credit goes, you could have the same answer as someone else and they can get 4 points partial credit on a 5-point problem, and you get 0 points, and that's huge. So notation is important. What about, especially here with this G of -3, G times the quantity -3 cubed? What would this be? -27 plus 5. Is it 27? 27 times 3, yeah. So 27 times 81, thank you. So this would be minus 81 plus 5, which would give me minus 76. So, sorry, my brain doesn't work all the time either. Like 3, 3, 3, 3, how many 3s is that? You guys can use any calculator in this course, so it's a good idea to have that calculator because once we get to maybe exponential and logarithmic functions, everyone inputs it a little differently. So if you need to put 5 second E enter, or if you hit E second 5 enter, there's various different ways to input it. So it's nice to have in class. This one, not too bad. Order of operations, if you in your calculator, it should come up with minus 76, but you have to be very careful with parentheses and exponents and things like that. Not too bad though, right? It's like, okay. So these functions are defined as followed. Simplify your answer as much as possible. I wanted to do the first one because it kind of also shows up on Alex. And some students like, I don't know how to simplify it anymore. And really, because your answer, you're done. It's as simplified as it gets, but sometimes students like, I have to do something else, and they do some crazy stuff. Square root of 5 is a number, just like 10's a number, just like 2's a number. It has every right to be there as any other number, but sometimes students are like, I don't want to see it. So f of 7, so I'm evaluating this function f at the point 7, so I plug in 4 plus the square root of 7 minus 2, 4 plus the square root of 5, which is just as pretty number as any other number. But sometimes students won't plug that in your calculator information, put it in Alex. Alex is not going. What about g of minus 3? Is it 5? Yeah, I got a little excited. Is it 5 or minus 5? So we have to be careful. 3 minus 1. So that tells me 9 plus 1 over minus 2, which gives me 10 over minus 2, which gives me minus 5. You can see the flow, and so if you do maybe drop the negative, I can see, okay, but he understood to plug in the minus 3, so he's going to get some partial credit there. If you just say 5 and no other work, I just say 0. Question?
The only thing I jumped to is I jumped from that first negative like that.
If you're correct, I'm never going to take off points. So if you do that and you're correct, you're fine. But sometimes seeing it, especially with negatives, if this was negative cubed and you jump to 27, it would be wrong because it would be minus 27. So just be a little careful. But yeah, I mean, if you're right, I'm not going to ever take off points saying you should have showed me more, because I could go into more detail than this. But I like to just kind of see the process, especially with partial credit. And then h of 2/3. So this, I'm looking at the h function. I'm plugging in 2/3, which is the absolute value of minus 12 plus 9 times 2/3 in absolute value. So I have the absolute value of minus 12 plus 6. So there's a few ways you can do it. You can say this is going to cancel out to 3, and 3 times 2 is 6. You can plug in your calculator, 9 times 2 divided by 3, and get 6. I'm not going to ever get on to you for using your calculator, but you want. So know what 9 times 2, in your calculator it's saying 9 times 2 divided by 3. Right? Or if you're careful, you can take 9 times open parenthesis by 3 close parenthesis enter. Right? So what our answer would be here? Absolute value of minus 6, which tells me 6.
Do we have to include the absolute value of negative 6 equals 6?
You don't know. You can jump. You could definitely jump here to say 6. But sometimes I like to see this just so also, you want to be careful that you carry the absolute value through until the very end. You actually take the absolute value. If you wanted to make the jump there, that's fine. Sometimes some students will forget about it. Be like, oh, -6, answer done. Nailed it. Not so much. Right, we've all been there. Any questions on this kind of stuff? You feel like it's Math 110? You guys did a lot of this in Math 110. No, just kind of notation. The next section is difference quotient, and the difference quotient is very important. I get to this. In calculus, the definition of the derivative is based on the difference quotient. So if I'm not saying you guys are going to get to calculus or care about calculus, this comes up all the time, section 2 points. You're going to have to calculate the difference quotient, and the very first part of the difference quotient is x plus h, or x plus 2, or something along those lines. And a lot of time it'll be x plus h. So what this means is everywhere I have a variable, I plug in this x plus 5. So if I need to distribute or if I need to square it, I need to make sure I'm very careful the way I write that. So let's look at g of x plus 5. I have 3 times the quantity x plus 5 minus 4 divided by x plus 5, then plus 5. Right? And I kind of put a little space there because if I put it in parentheses, you guys see how the x is the variable and x plus 5 is what I'm plugging into that x. So this one is pretty straightforward. The first step, I'm going to distribute my 3 to both x and 5. So I have 3x, x, plus 15 minus 4 divided by 10. And then the second, just 3x plus 11 over x plus 10, and that is my answer. There's nothing more to do there, as simplified as it gets. It doesn't show up on we're doing this, but I'm going to give you the quiz, and on the quiz, the x is squared. So if you had x plus h, or let's say x plus 5 squared, you guys know what that would end up being?
X squared plus 25.
Yeah, so what this notation is saying is the x plus 5 quantity squared is x plus 5 times x plus 5, right? So this is going to be x squared plus 5x plus 25, and some of you might have said, oh, that's x squared plus 10x plus 25. If you came right from Math 110, you're like, I did this for 4 weeks straight. I know exactly what a plus b quantity squared is. That's a squared plus 2ab plus b squared. If you're not there, that's fine. Take the time to write that out to get what it's going to be. If you've done it 500 times like they expect you to do in Math 110, you can jump ahead and say, okay, I know that's x squared plus 10x. You still do it that way. And that's perfectly fine to see it out and you know exactly where you're going. Instead of saying, I don't like jumping over this bridge, I want to see the bridge is sturdy. Okay? So this one comes on the quiz I'm going to give you in class. And the quiz in class is not like, oh, no notes, no books, no talk. You know, I want you guys to somewhat interact with it. So I'll kind of walk around and give you feedback. But I want to also collect it and be able to act that way. Here's from Alex. So if I wanted to transform this function, you guys could probably barely see it on your handout, but this is x squared. And on the quiz, I might just say graph this graph, and you need to know this is the graph of what x squared looks like. So I need to take that general graph and shift it right or left. Right, 3 units, right? So not anything. Maybe 1, 2, 3. I won't take off points for it, no. I won't take off points unless it specifically says show this step or do this method or something like that. if it's a yes or no, you'll usually say, is 3 a 0 of this polynomial? You say yes. And if it's right, you'll get 1 point, but it might be a 9-point problem where you have to say, you have to do this method and test this and verify it. But I would say justify your answer that way. But most case, no, yeah. For graphing, there's not a lot of work to show. It's your answer. And some problems are like that. And if you did one of the problems above and you put -7 and didn't show me anything, that's right. I'm going to give you points for that. So it's risky to do though, because if you do something, you're going to get 0 out of the 5 points versus guaranteed a point by just plugging it in. Guaranteed a point by doing it this method. Next, absolute value problem. So again, you might be expected to know what the absolute value of the function looks like, and then be expected to graph this. So know the absolute value function looks like this. So this point gets transformed over here. If I wanted to take this point, got off the graph. Maybe I'll take this point, go over 1, 2, 3. If I take this point, 2, 3, 1, 2, 5. And the graph of the function that would look like the one. Definitely.
Goes right 3.
It goes right 3 because it's x minus 3.
Oh, okay.
Right.
So
the
the
same thing
minus-
here.
Okay.
It's the minus.
I wasn't sure if the minus on that one. I know you talked about it last time, but I didn't really.
Yeah.
check. I wasn't sure if the minus was only because it was, or the right was only because it was squared.
Yeah. No. So that's a good point. Anytime I have x minus c or x plus c,
It's always.
it's opposite of what
Right,
you
and
think
then
of.
that.
Yeah, it's counter to the same thing when I have 2x and 1/2 x, right? This one is going to change x by a factor of 1/2,
Okay.
right? And this is going to change it by a factor of 2. Versus if I have 2f of x or 1/2 f of x, this is going to be normally what you expect. The 2 increase it by a factor of y, saying y equals. So yeah, it's kind of what we sometimes is seeing it in the fresh light. But anytime you deal with the x, it's counterintuitive to what you think. It's exactly what you would expect. Plus 5. If I had something like this, plus 5, that's affecting the y. So I was going up 5. Minus 5 going down 5. If I have y equals 2 times f of x, that's going to change your y-axis. It's going to change your range by a factor of 2. Here, if I have 2x, if I replace my function with 2x, that's going to change my domain, and it's going to smush it in by a factor of 1/2, right? Because you always take your x value divided by a. So if you divide by 1/2, you're really multiplying by 2. And we'll do some of those stretching and shrinking on the next page. But step is understanding the shifts, and x is kind of counterintuitive. X minus 3, that's to the right 3. X plus 3, that's to the left 3. We did this kind of very similar to one in class. If I had this graph of this function and I wanted to translate it vertically down 7 units, then what would look like the old graph minus 7, which would simply be minus 5x squared minus 2 minus 7, which is minus 5x squared minus 9. So that's what the new graph would be like. Example has a lot to do with notation. So this is saying, for what value of x in the function does the output equal 4? So what value in my domain gives me a range of 4? 0, right? If I plug in 0 to my function, I come out with 4. So this answer here, x would equal 0, then f of 0 type kind of approach, right? What is f of minus 2? It looks like 2. It is 2. Right? So that means if I plug in minus, my output is 2. So here, f of minus 2 would equal 2. So the first question is asking, for what input do I output for? The second question is, for what output, what do I output when I input minus 2? And then we can talk about the x-intercept and the y-intercept, possibly in Alex. They'll ask you to x-intercept and the y-intercept to know what that means. An example of a, if I have the original graph of the x, and I want to graph y equals 2f of x plus 3. So nothing, I'm not plugging anything new in x, right? So my x for minus 4, so my still go from, but my y is affected by a factor of 2, right? So if I plug in minus 4, when I plug it into my new transform function, I get minus 8, right? So really, this purple graph would equal y equals 2f of x. So I'm not done yet because I have to add the plus 3, right? So if I want to add 3 to that, I take every point and add 3. So this new point becomes 1, 2, 3, 1, 2, 3, 1, 2, 3. So my red graph is actually 2f of x plus 3. Which is the exact same, but my domain changed, right? It went from 0 to minus 4 to when I took 2 times f of x, it went from 0 to minus 8, and then I shifted it up 3, minus 7 to 3. So sometimes graphically can come in handy when we look at domain and range and what's going on there. If I want to say what is the new domain and range, looking at the graph can help me find that. The domain stays the exact same because I didn't manipulate x in any way. I only ever manipulated the output. You see that? 2f of x.
What did the 2 do?
The 2?
Yeah. Did it just multiply?
Did. So I took every point to a 0, and 0 times 2 is 0. Here, minus 2 originally outputted to minus 4, I think. So my new output would be 2 times minus 4. So I only manipulate, the purple was only looking at the 2f of x. And then once I had the 2f of x at every point and shift that up. You could have done it all in one step. You could have said, okay, this times 2 is 0, and then add 3. This times 2, and then add 3. And then this times 2 and add 3, and gotten the red graph straight forward. Because basically that's what you're doing every point here. You're taking this point, you're multiplying it by 2, and you're adding 3. So this becomes a new point. Right? You're taking this point, you're multiplying it by 2, and adding 3. This point, multiplying it by 2 and adding 3. You could do it to this point, multiply it by 2, and then add 3. And you so straight, these points have to connect. So usually when you do it to endpoints or critical points, on your quiz, you have to be a little careful. I shifted it a little bit too much and go off the graph a little bit, but just go with it. Does that make sense there? So f of 2x. So this is telling me the range. The range needs to stay the same. The don't usually put in, then I say, okay, what is my new x point by 2, which tells me -1. So at -1, my output value is the same as what it would have been in the original function at -2. So this point, this point, this point. So the 2 inside the parentheses took the domain and shrank it by a factor of 2. Right? It didn't range. Your lowest point and your highest point is still your lowest and your highest point. It just happened much faster. It's kind of think of if you watch it like if you watch a movie, if you watch it in double time, the exact same things happen, it just happens faster over a shorter period of time. So you can think of that. You have, you know, abilities to change the speed of your video. If you're changing it by a factor of a half, everything happens just over a longer period of time. Your domain by a factor of really twice as long if you're watching it half speed. You have a 2-hour video and you're watching it at half speed, it's going to take you 4 hours. So you're going to draw that just more dramatically. Does that help anyone? If not, I don't know. Are you like, okay, good. I try to come up with sometimes it does not end up well. So just nod, smile. It's Friday, right? So looking at this graph, I want to output change, range changes. Range changes by a factor of a half. So start here, it's still going to end here, but instead of going all the way to this -4, I'm only going to go to -2. So 0, 0 never really changes when you're anything. It only changes when you shift up or down or left or right. So this is just saying, I take the function, multiply it by a half. So time, but you only get half of the output. You guys see that? It goes from -2 to 4, but it's not as dramatic. It doesn't go as far. Originally, now it's only going to go to -2. Here it went to -2, so now it's only going to go to -1. Interesting in calculus critical points, because we don't really care what happens in between them. Connect dots, you're done. This next example is the y is changing, right? I'm not doing anything different with the x. So my x needs to stay from here. You don't have this page. I got gypped a page. Sometimes the printer goes really fast and got lost a page. All right. Well, there's not anything too exciting in these two examples. So I'll go ahead and give you guys your quiz. You guys on this. I'll select it. We can kind of talk about some of them. Yeah, so we're individual for maybe 5 minutes. So you actually have something to compare. But it's not like you have no support on it. If you're totally lost, let me know and I'll kind of talk it through. And then in about 10 minutes, let's then kind of compare with our neighbors and say, are you right or am I right? Because we both in there. Hopefully you get the same answer.
Is this one supposed to have a graph?
You're supposed to graph it. So you're supposed to go to know, yeah.
Oh.
So yeah, on the quiz on the 2.6, I didn't say this is x squared, but you should know what x squared looks like. This is just that little disconnect from Alex, right? Because you're like, I'm supposed to have a graph. I pick up with my mouse, move over 3 and up 4. I can't do it any other way. So just to give you a little bit of exposure.